Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on calculus, and this is question number 21. Okay, this question is a little bit tricky. What we're going to do here is, well, first of all, let's see what they're asking us. This function is defined, this kind of a strange function. It's defined in terms of an integral between x and 2x, a definite integral. And we're asked at what value of x in the interval 0 to 3 pi over 2 does the function attain a local maximum? Well, when we hear that word local maximum, we know that we're going to have to take a derivative, set it equal to 0. So we want to look for f prime of x. That's our big question. What is f prime of x? Well, to differentiate this function, the trick is to think about this. We know from the fundamental theorem of calculus that the derivative of an integral somehow ends up being the function inside the integral, the integrand. But we've got this x and a 2x as the limits of the integration, so it's not exactly just sine x over x. We're going to have to think about this integrand, sine t over t. If you think about it, if you define big F as being the antiderivative or indefinite integral of sine t over t dt, okay, then you know that f prime of t is equal to sine t over t. So if we evaluate supposedly this function f of x, we can rewrite it as big F of 2x, because it's a definite integral, so we have to take the antiderivative of 2x and subtract the antiderivative at x. Okay, and if we're looking for f prime of x, well, that's like, we're going to have to use the chain rule here. That's going to be big F prime of 2x times the derivative of 2x, which is 2, and then subtract the derivative of big F with respect to x. Okay, well, this now we know what this is. Since the derivative of big F is sine t over t, then this is going to be sine of 2x over 2x, but then times 2, so that's just going to be x, and then subtract sine x over x. So we actually have a common denominator. Okay, good. So now this is our derivative, and we're going to set this equal to 0 and solve for x. So the x in the denominator isn't going to do anything here because we're not interested in what happens when x equals 0. So what we want to know is when is sine of 2x minus sine x equal to 0. In other words, when is sine of 2x equal to sine of x? Well, this is like asking which angle has the same sine as its double. Well, let's think about it. If we look at the unit circle, well, I think if we look at pi over 3, remember the sine of pi over 3 is root 3 over 2, and then 2 pi over 3 is going to be over here, and it's going to have the same sine, root 3 over 2. And the other option is pi. 0 is also an option, but again, we're not interested in 0 because it's outside of this interval, 0 to 3 pi over 2. So, but pi is also going to be work because sine of pi is 0, and then sine of 2 pi is also 0. So I think our options are x equals pi over 3 or pi. Another way to solve this equation is to use the double angle formula. Remember that sine of 2x is the same as 2 sine x cosine x. So if you write this out, then then you know that either, well, you can factor out a sine x. So you know that either sine x has to equal 0, which gives you the pi solution, or that cosine x equals 1/2, which gives you that x equals pi over 3. Alright, so now each of these gives us some either a local maximum or local minimum, and we have to check each one to see which one is it. Is it a local max or a local min? Because we're interested in the local max. And both of these are possibilities. We've got a pi over 3 and pi. Okay, well, let's scroll up a little bit. In order to decide if each one is a local max or a local min, we're going to have to check the second derivative. Remember, if the function is concave up at that point, it's local min. In other words, if the second derivative is positive, and if it's concave down, or if the second derivative is negative, it's going to be a local maximum. So let's write out what the second derivative is. F double prime of x is going to be, let's use the quotient rule. The quotient rule says take the denominator, x, multiplied by the derivative of the numerator. So that's going to be cosine of 2x times 2 minus low d high. Okay, and this is still cosine x. Okay, that's the derivative of the numerator. So that's low d high minus high. So now we're doing sine 2x minus sine x. D low, which is just 1, and then we square the denominator. And away we go. So now let's plug in pi and see if that gives us a positive or a negative second derivative. Well, f double prime of pi is going to give us pi times, well, what's cosine of 2 pi? That's going to be 1 times 2 minus cosine of pi, which is negative 1. So it's going to be plus 1 altogether, minus sine of 2 pi, that's just 0, minus sine of pi, which is also 0. So it looks like we're going to have, and then on the bottom it's going to be a pi squared. So this is going to be a positive number. So right away we know that at pi we're going to have a local minimum, which means that that's not the answer, and we can eliminate it and just select pi over 3 as the answer. But just to make sure, let's figure out if the second derivative of f at pi over 3 is negative. Well, we're going to have pi over 3 times the cosine of 2 pi over 3, which is going to be a negative number. That's going to be negative 1/2, times 2. So that gives us a negative 1. And then subtract the cosine of pi over 3, which is going to be a positive 1/2. So this whole thing is going to be negative 3/2. And then subtract the sine of 2 pi over 3. Right, this is going to be, what is that, minus sine of, well, we know that sine of 2x is the same thing as sine x. That's how we chose x. So this is just going to be minus 0. And all of this is going to be over some positive number, which is pi squared over 9. So yeah, this is going to be a negative number, which means that pi over 3 gives us a local maximum. So our answer is B.